Next is your geophysical method. It is used for location of different strata. Location of different strata, soil strata. Also used for location of water table also. It is an approximate method. In geophysical method there are two methods. One is one is seismic method, other is your reflection method. Now, part A, seismic method. Let us say 3 layers of soil, say layer 1, layer 2 and this is your say layer 3. A, B, C, where geophones when installed regular interval in the ground surface. This is V1, V2, V3, V1, V2, V3, then V2, then V1. So, this is O, this point is O. What is the procedure? Procedure is first shock wave generated at point or created by a hammer, say at point O. Then a shock wave travels through soil, the observation of fast arrival wave recorded by geophones located at point A, B, C. Geophone converts ground vibration to electrical impulse and transmit it to your recording apparatus. Assumption is shock wave increases as depth increases. As depth increases. So, in this case B3 is greater than B2 is greater than B1. Now, if you look at this seismic method, first of all geophysical method, this is an approximate method. So, used to find it out the different soil strata, like if there is a ground surface here, suppose there are 3 layers, layer 1, layer 2, layer 3, at what distance from the ground surface, say x1, say x2 or say x3, how do you know that at what distance at the ground surface below here the subsoil soil strata changes? It can be done, there are various methods by means of boring, auger boring or hand boring you can do it, or you can do it also geophysical methods without doing any boring. So, as this is an approximate method, there are also limitations. In this case geophysical method has again two methods, one is your seismic method, other is your reflection method. In seismic method, what is the procedure? If you look at here, in seismic method wave is created, this is called shock wave is created. That means, suppose let us say this is point O, at point O shock wave has been created by means of hammer. Here you hammer and shock wave you created. At the same time, from this is called source. From source at equal distance you put geophones A, B, C, you put these geophones, then what will happen? The moment shock wave you create, it will first travel from here to here, it will be receiving by this, by velocity v1 first geophone located at point A. Then the shock wave also will travel at a velocity v1 in layer 1, then it is reflected in layer 2, then again it will be refracted, so that you will receive wave at point B. Similarly, for third layer it will go, you will receive wave at point C. So, first arrival means the moment you start create the shock wave from this, from ground, from here source to here, this is source and these are receivers. In these receivers, first arrival of these waves at this from this point to here, it will be received at station A, B and C. So, what is the principle of geophone? Geophone, whatever located here, it converts ground vibration. What happen? It converts the vibration to electrical impulse. That means, ground vibration will be created by from the source by means of impact, and it will by impact this vibration will start from layer 1, layer 2, layer 3. So, it will convert this ground vibration to electrical impulse and it record as a receiver how much time it takes to receive this waves. Then this another limitation you can say, the assumption is shock wave to be increases as depth increases. That means V3 is greater than V2 is greater than V1. V3 is your velocity at layer 3 is greater than velocity at layer 2 is greater than velocity at layer 1. Let us say this, how you are going to find it out, H1 and H2. This is my layer 1 and height is called, let us say this height is called H1 and this height is called H2 and this height is called H3. If I plot this arrival time for first wave, arrival time for first wave, say t, so distance from the source, it is distance from source this is alpha 1 alpha 2 alpha 3 x1 x2 if I write this is my V1 and this is your V2 tan alpha 2, V3 is equal to tan alpha 3. This will be, you can say T1 plus T2 arrival time, say this is my T1, this is my T2. For a certain distance, say x1, x1, the direct wave in layer 1 the direct wave in layer 1 for a certain distance x1, it reaches first. It reaches first. Similarly, at this point, two lines intersect which indicate direct wave travelling at a distance with a velocity v. If you look at here from this graph, these 2 points intersect. Here is your direct wave you are getting at a distance velocity v1, this is your x1. Now, similarly, at a distance time t2, so refractor wave travelling with velocity v1 and v2 at a distance 2h1. If you look at here from here to here, it is your direct wave you are receiving by means of geophone at a distance x1, it comes first. Now come to layer 2, that means in this case only h1, in this case h1 and h2, it is travelling, what is the travelling distance? This is V1, V2 and V3. V1, V2 and V1, not this is V3, V1, V2 and V1. To V1 plus V2, it is travelling with a distance h1 plus h2. Now, if I write x1 by V1, x1 by V1 is nothing but, if I write x1 is a distance travel from to here by V1, that is your time, t, which is equal to also 2 h1 by V1, because in case 1 you are getting direct, in case 2 the wave is from this source, it is travelling twice at the velocity V1 and V1. So, it will be 2 h1 by V1 plus x1 by V2 plus x1 by V2, which is equal to, again this is time t, you can get it from here, h1 is equal to V2 minus V1 by V2 into x1 by 2. If I plot a graph between arrival time for fast wave t versus distance from the source, if you look at here, first this is your first, it is your source, from here to here how much time it takes? It takes t1, from here to here it takes, which is equal to distance travel. What is the distance? Distance is from here to here, let us say x1. So, x1 by V1, that is your time. At the same time, if you look at here, at the same time t1, because it is within this frame of time t1, this and this, at the same time what will happen? It travel from here to here with velocity V1, then reflected with velocity V2, then refracted with velocity V1. That means twice there is velocity V1 with a height of h1. So, 2 h1 by V1, that means it travel a distance, in this case h1 become a distance, here x1 become a distance, in this case h1 become distance, because it travel from here to here, that means it covers the distance h1, then it reflected, then it travel with a distance say x1, then it again refracted back, again it travel with a distance h1, that means 2 h1 by V1, x1 by V2, this is your time, from where you can get it, how much is your distance or maybe h1. At what distance from the ground surface the layer changes, that you will get it from this graph. Similarly you can find it out h2. How do I get h2? I will take this as well as this and this, that means in this case h2, it will travel from here to here with a distance h1. In this case, to find it out h2, if you look at here the source from layer 1, layer 2, layer 3, again it refract, that means h1, that means 2 h1 by V1, then h2, this is your V2, then h2, that means 2 h2 by V2 plus V3 x2, that means x2 by V3, then you can easily find it out what is the value of h2. There are also empirical relation by means of impact shock. This is given by, this graph has been drawn based on your reflection as well as a refraction by empirical or impact shock. For impact shock, by means of empirical relation, H1 is equal to x1 by 2 V2 minus V1 by V2 plus V1. Similarly, distance S2, as I said, distance S2, how do you get it? H2 is equal to 0.85 H1 plus x2 by 2 root over V3 minus V2 by V3 plus V2. So, similarly, you can find it out S2 also by the method of principle of reflection and refraction. So, there are two assumptions in this case, you can say. One assumption is that the moment your shock wave generate, it will travel by means of reflection or refraction. That is your one assumption. That means, from here this wave will generate, it will go, it will reflected here, again it will come start travel, again it will be refracted and it will go. This is case 1. Case 2 is that impact shock, it will travel impact by means of here and there by impact. So, by means of method of reflection and refraction, you can find it out H1 as well as H2. So, H1 I can get it V2 minus V1 by V2 into x1 by 2. H2 I can get it 0.85 H1 plus x by 2 V3 minus V2 divided by V3 plus V2 root over. Now, there are some standardizations. Materials, then this is the velocity meter per second, sand, sandy clay, gravel, rock, water in loose material, sandstone, then lime. In sand it is 180 to 365, sandy clay 365 to 580 and gravel 492, 790. Then your rock is your 402, rock there are different types, I can write rock talus 402, 760, water in loose material it is 1400 to 1830, then sandstone 915 to 2750, then limestone is 1830 to 6100. These are well developed, means if this material, suppose say I got the velocity, I got the distance h is like whatever the distance, maybe 2 meter 5 meter, but whatever I get it from the velocity from here with this time, I get 180 to 365 velocity meter per second square. That means it will say that with this distance h1 there is a sand layer. If it is 180 to 365, then you can say this is sand layer. Suppose it is said like 1400 meter per second. In that case, you can say that there are some loose sand with water. That means water is there. With water is there, loose sand with water is there. So, with this material, this has been standardized. So, there are also limitations. What is your limitations? This method has also limitation. Cannot use hard strata. With a greater seismic velocity overlies a softer. Cannot use harder strata lying over softer strata. Cannot use area covered by concrete. Cannot use frozen soil. Case 1, it says cannot use hard strata lying over soft strata. So, it is if there are hard strata, then this is soft strata. So, what will happen? The hard strata, it will refract, and whatever wave come to the soft strata, it will absorb all these things. That means, it should be soft, slightly softer, then this will be slightly harder. This kind of assumption should be there. Cannot use area covered by concrete. If this area has been covered by concrete, this wave may not propagate beyond the concrete. Also cannot use these frozen soils. In European countries where the soil becomes always frozen state, this method cannot be used. Now, we will go for solve one example from this seismic reflection method, refraction method. So, it says a seismic refraction study of an area has the given following data. So, this is your distance from impact point to geophone. Time to receive waves. It is given 15, this is in terms of meter, 15 meter, 30 meter, and time to receive in, you can say second, 15, 30, 60, 90, 120, and 0.025, 0.05 second, 0.10, 0.11 and 0.12. So, what has been asked? Plot time data, find seismic velocity, for surface and underlying layer. Then find thickness of upper layer, now with this data, first you plot your time versus the distance, travel distance this is 60, this is one point, this is other point, 15, 0.025 second, this is your say 30, this gives how much? 0.05, increase it, it gives 60, then it will go up to 0.10, then afterwards $90, this will give 0.11, then 0.12, and this will give 120. This is your distance and this is find time. First plot your time versus distance. You will find it out, there is a breakage in this line, clearly there is a reflection. If there is a reflection, the line will change its path. So, first up to 0 to 60 second, it goes straight line. With increase in time, the distance increases, it goes straight line. After 60, there is a reflection. You will find it out, there is a reflection. So, this is given well documented and you can find it out, say this is my V1 and this is my V2. Now, we can calculate from this formula, V1 is equal to 60 minus 15 divided by 0.10 minus 0.025. Velocity is equal to distance by time. So, distance 60 minus 15, so it will be 45 and 0.025 minus 0.1. So, this will give 600 meter per second. Similarly, V2 from this graph I can find it out, 120 minus 60 divided by what is the time corresponding to the time 0.12 minus 0.10, it will be 3000 meter per second. Now, this is the velocity, means velocity profile you will get it, velocity is nothing but this is your distance by time. From this graph distance by time you can easily calculate your velocity. Now, once you will get velocity, then you can calculate from here what is your time, means what is your thickness H1 as well as H2. Now, find it out H1 which is equal to x1 by 2 root over of V2 minus V1 by V2 plus V1. So, which is equal to 24.5 meter. As it has been asked thickness of only upper layer in the question, maybe thickness of lower layer you can calculate. So, the question is plot time data, find seismic velocity for the surface and underlying layer. That means this underlying layer is, this is your underlying layer, because this velocity profile it says it reflected. So, V1 and V2 we calculate, then from there H1 has been calculated. Then with this V1 and V2, with this velocity, can we predict what is the material or what kind of soil it is, say soil 1, soil 2. As I said earlier from the chart, as V1 says 600 meter per second, so maybe hard clay or maybe you can say clay. As it is 3000 meter per second, it will be a sand rock. Based on the velocity profile, whatever velocity we get it, you can classify it may be hard clay and bottom one is sand rock. That means with this method you will get, you can predict what is the probable of soil, what kind of soil it would be. It may be a hard clay and layer 2 is sand rock. Based on the detailed soil classification, you can confirm whether it is hard clay or sand rock. Then for soil 1, layer 1 and layer 2, thickness can be find it out. The thickness is your first layer thickness is your 24.5 meter. Once you find this thickness, you can say that up to this thickness hard clay is there, beyond this it refract, this has been reflected or reflected. So, H1 and H2 you can easily find it out, as well as what kind of material is there inside, you can find it out.